Good day, everyone. My name is Gihan Kamel, and I'm speaking to you from Jordan, a country at the heart of the Middle East, a region often described as one of the most volatile and complex in the world. Today, my presentation will not delve into technical or scientific details. Instead, it's meant as a moment of reflection, a contribution to a larger question. What is the role of science diplomacy? And in particular, what is the role of science diplomacy in the Middle East? I would not pretend to have the answers. This is a journey that is still unfolding. We cannot yet say with certainty whether science diplomacy is just a hopeful slogan or an emerging reality. In a region that is as fragile as ours, the future is not some distant horizon as in the rest of the world. It is tomorrow, it is tonight. The future for us can be perhaps even by the time we finish this presentation. But there is an even deeper question that I'd like us to consider beyond the technical or the scientific advancement. I'd like us to consider it as scientists and as human beings having a message to deliver. Why is it that we often speak about dying in peace or resting in peace, but so rarely of living in peace? What I hope to share with you today is a series of short reflections, key messages drawn from our experience with the single particle accelerator in the Middle East named SESAME, the Synchrotron light for experimental science and applications in the Middle East. A remarkable scientific collaboration that brings together countries. Those are Jordan, Egypt, Palestine, Israel, Iran, Turkey, Cyprus, and Pakistan. It's a story of what is possible to do when science becomes a bridge. Before going deeper with these reflections, I'd like us also to consider the perspective, because perspective keeps proving itself that it really matters. And I just take this cartoon showing two gentlemen. One is seeking a boat and the other one is seeking a land. And clear enough to say that both need each other in a way of proving that complementarity matters, that we need each other. The other point that I'd like to highlight here, which is often taken as a factor when we categorize the world, when we say the developing countries and the developed countries, is highly dependable on the financial resources. However, who knows if these two gentlemen are poor or rich? They can be millionaires, they can be billionaires. Yet, money here is not considered a factor. What's important is how can we help each other? How can we complement our resources? And how or when will we understand that money cannot solve all our problems and challenges? It's certain enough that financial resources are of paramount importance. However, for some other aspects, it proves that it's really not enough. I'm talking about a particle accelerator that's like a large-scale research infrastructure. There are so many of these particle accelerators in the world. There are above 50. but SESAME is the only one in the Middle East and the neighboring regions. The key message that such large-scale infrastructures known as synchrotron light sources or synchrotron radiation facilities that is pointing out to a very important message that science knows no nationality, and there is nothing that we can say or no way to say that we have a national science. Science is meant to be shared across the whole world. When we were hit with a virus, this virus hits the whole world. It's true that some challenges or some problems or some diseases or some environmental aspects are somehow related or relevant more to geographic locations than others. However, science is meant to help whoever is passing by such a challenge or such a problem. And since I'm speaking about synchrotron light or synchrotron radiation, it's just worthy to know that synchrotron radiation was already observed 6,000 light years away as Crab Nebula. However, it was also observed in the labs in 1947, and since then, so many advancements and bright, as far as it's also a bright radiation, bright, innovative, and bright developments were already observed and implemented using the unique features of synchrotron radiation. And here I cannot say, as I said, for science diplomacy, if it's a hopeful slogan or not. I can say with certainty that with synchrotron radiation, we can see the invisible. We are illuminating science. Here, it's not a slogan. Here, it's a scientific reality. This kind of radiation that's spanning from X-rays to infrared, ultraviolet, and visible can have a fingerprint in all applications ranging from basic science, physics, chemistry, biology, to applied science, environment, to medicine, life science, material science, energy, batteries, catalysis, chemistry, geophysics, not only to help us to understand the present and to work for the future, but it also can give us a very nice opportunity to explore our past. It gives us the opportunity to explore and investigate archaeological and cultural heritage materials. And to give you a quick panoramic view of how we are employing this kind of radiation in whether at SESAME or other synchrotron light sources, I take you across the particular applications those are dominant to be implemented in these facilities. We can shed a lot of light on information related to chemistry, to biology, material science, energy and batteries, microelectronics, pharmaceuticals, drug design, environment, forensics, medicine, and also trying to get new drugs for persistent diseases and viruses as well, quality control, textiles, forgery detection as well. Industrial sectors benefit hugely from synchrotron radiation, as well as cultural heritage archaeology and paleontology. And not only that, we can so much help with art restoration and conservation protocols for our precious ancient heritage. These are some examples of how synchrotron light sources helped to develop new novel and new drugs for persistent infections such as influenza, SARS, hepatitis C virus, West Nile fever, and COVID-19 is not a far experience from us, where all synchrotron light sources came at the front line to find a quick and effective vaccines and drugs to fight such a pandemic. Not only to work for persistent viruses or microbial diseases, but also it's well known that the techniques available at synchrotron light sources can allow us to understand better the pathological aspects of diseases in order to diagnose them better, in order to cure them better. And these are just a few examples of what synchrotron light sources could help the humanity with. For example, in understanding the stroke, understanding the neurodegenerative diseases such as Alzheimer, mad cow disease, Parkinson, multiple sclerosis, as well as, for example, preeclampsia and dermal drug delivery systems. To come quickly to our region and to start giving the key messages about SESAME, we realize as scientists and as human beings living in this region that we have similar and complementary aspects such as culture, such as our common language, common history, somehow very, very close geographical borders. However, we cannot say again that these similarities between us can help us to solve our regional shared problems, because it proved that it's not enough. So these similarities proved us wrong, that it's not our nationalities, it's not our geographical locations, it's not our religion, it's not our traditions, it's not our culture. We need something more, and these factors prove to be not enough. The major factor that we are lacking in our region is peace. You cannot think of advancing science and technology while you are in a region that's tinted and like fingerprinted with turbulence, instability, wars, and political conflicts, because these things shed light on our daily life and also on our ability to think and ability to develop. It's not strange to find so many books and articles talking and discussing about war and peace in the Middle East. Everybody wants to understand what's going on in this region, and it's not strange also to find a book titled "What is Really Wrong with the Middle East?" I would say that the point is not to think what's really wrong. The point, or the most important point, is to think what's really going right. And SESAME is one of the examples that shows that at least for some aspects, something can go right. This is the theoretical map of the region. So lots of countries and borders and relationships, whatever it is. But this map is the experimental one. Our map is not that simple. There are a lot of intrinsic realities that go beyond the geographical borders. And everything is related again to interests and to relationships. And again, the region is tinted once more and going once more from bad to worse, from conflicts to wars. And I could count 7 countries those are involved in either political conflicts or wars at the moment in this region. SESAME, that's located in Jordan. Its acronym is again Synchrotron Light for Experimental Science and Applications in the Middle East, proves that despite all the conflicts, despite the wars, despite the destruction, despite the frustration, despite the sadness, this facility is still running. And I'm talking to you from here, from there, from my office in this facility. SESAME has a long journey that started like more than 25 years ago when Germany decided to dismantle its Synchrotron BC1. And some people at that time, those are major key players for us. They thought, why don't we take it as a seed to have the first synchrotron light in the Middle East? And this ship that you see in the center of the slide, those are the components of the dismantled German machine in 2002, leaving Hamburg, going to Aqaba in Jordan. However, as long as all these people know that this region will be always susceptible to conflicts and wars, they understood that a major and extensive upgrade had to take place, otherwise it wouldn't be competitive if it comes operational after more years. And they were totally right. So they went for brand new machine. We are still using parts of the main injector of the main German machine. However, we have a totally and brand new accelerator now. And if you see that between the photo in the center and the photo to the right, it took like 20 years to bring this facility into operation. SESAME is modeled on CERN, taking it as an example of CERN when it was established by physicists and diplomats after the World War II. So it was the first major, brilliant example on science diplomacy, and SESAME is taking the same route of CERN. It's an intergovernmental organization at the service of its member. It was established with so many efforts by UNESCO, and those countries you see here in this slide, those are SESAME members. Those are Jordan, where it's located, Turkey, Palestine, Cyprus, Egypt, Israel, Iran, and Pakistan. We have a non-ending story of collaboration and cooperation with our observers. Those are listed here. Major drivers to our existence, as well as our sustainability so far along so many years. A lesson learned very well that we can, of course, establish successful bridge building through scientific collaboration. And that means if we are following the example of CERN, that means you have to establish scientific collaboration as well as diplomatic efforts. But so if you are thinking with diplomacy, we also learned the lesson that diplomatic science does not work, and you need to provide excellent science to be considered the major driving force in order to have sustainable and sound bridges. And that means we have in our equation not only powerful diplomatic efforts, instead we have also to add the excellent science component to ensure the sustainability and the competitiveness of such a facility. This is what I can call science diplomacy in action. This is one cell of the 16 cells of the particle accelerator, the storage ring. It was designed and commissioned, tested at CERN. And in this slide, in this photo, you can see a SESAME engineer at CERN attending the magnets testing for the accelerator. And you see that Spain, France, UK, Germany, Turkey, Cyprus, Pakistan, Italy, Switzerland, and Israel. This is a combination of, or like a convolution of efforts between members and observers, how they manage each with expertise and with financial resources as well, and skills to bring together all these components for the sake not only of science but also with a hopeful seeking of peace. And this is very basic equation for any scientist. It's like 1 + 1 = 2. No geographical borders, no nationalities, no religions, no traditions, no cultures can stand in the way of scientists if they want to collaborate. And this map that I show here to the top right, this is the map as seen by politicians and diplomats, full of borders. But for us scientists, it's the one to the bottom right. No borders should divide scientists from working together for the sake of humanity. This is like a collage of I collected from our different sources of users, of SESAME staff, of SESAME supporters, directors, president. I don't want to say that it's like a family, but it's really a family. We are really of a limited number of staff. We are like 70 or 72 person. So this facility is really running with a few people, but the skills and the enthusiasm and determination and patience, dedication, persistence helped us a lot to grow from nothing to everything now. And I wouldn't forget Abdus Salam, who was the first person to think, the Nobel Prize laureate, of course, the founder of the ICTP, International Center for Theoretical Physics in Trieste, Italy, who said that we really need to have a facility of this kind in the region. And he thought of this in the 80s, and we had it now. So he had a very long vision for such a project. And I cannot also forget one of the very nice African proverbs saying, if you want to walk fast, walk alone. If you want to walk far, walk together. I think that we are really applying this African proverb here. Otherwise, we wouldn't be able to bring this facility to reality. This is the opening, it's for us, this is a historical moment. It's the opening ceremony of SESAME, the inauguration of the facility that was in 2017, starting from His Majesty King Abdullah II of Jordan, and so many key persons here. I don't want to forget any, but here you see CERN, you see the IAEA, you see the UNESCO, you see the EU, you see the delegations of the members. It's a convolution of determination of these people to do something right in the region. And we're really so thankful for every single person in this photo and beyond. There are hundreds of people those are supporting us from birth, from the first day until today, and we are confident that they will keep supporting us. I don't want to say forever, but as long as it takes, we are sure that they will be backing us. In 2018, SESAME became the first associate of LEAPS, that's the League of European Accelerator-Based Photon Sources. And in 2019, SESAME became the world's first large accelerator to be fully powered by renewable energy with a very generous support from the EU that was in the order of 7 million United States dollars. We are also so much committed to the climate change agreements, and we signed the climate neutral now, and we are also aligned with one of these very nice slogans with a Swiss company that for vacuum components, where they said SESAME Synchrotron 100% synchrotron light and 0% carbon dioxide. This is a view of the facility. It's a third generation light source, top energy 2.5 gigaelectron volts and circumference of 133 meters. And we are having so far 5 operational beam lines ranging from XAFs, X-ray fluorescence, infrared microspectroscopy, material science or X-ray powder diffraction, beats for tomography, as well as HESIP for soft X-ray spectroscopy, and TechSpace is the beamline that's under construction now. It's a game changer because it's the first beamline at SESAME that's funded by a member that is Turkey. So it's a Turkish beamline at SESAME, which for us gives an impression and indication how successful the facility is. Further than that, we are doing a lot of efforts with Africa, since Africa is the only facility that's left without such an advanced, the only continent that's left without such advanced facilities. So we are trying to establish also maybe the first African beamline at SESAME. Meanwhile, we're working for the first African light source. We're also aligned with the International Science Council of the missions for sustainability, as well as the 17 Sustainable Development Goals. We are covering many out of these 17 goals. Not only for science and technology, we are also have fingerprint on what we call brain drain challenge, and SESAME is managing to reverse this severe problem with the large-scale immigration of technical and scientific skills are fleeing out of the region. SESAME is trying to retain and reverse and bring them back to the region. Not only that, SESAME is an equal opportunity facility, and we are trying to enhance the gap of women in science and women in engineering in the Middle East, and I can confidently say that we are succeeding brilliantly in doing this based on our statistics, whether for the SESAME staff or the SESAME researchers and users. This is a long list of users, nationalities coming to SESAME, not only from SESAME members, but also from SESAME observers, like from Germany, like from Italy, like France, the UK, Japan, Belgium, and this proves to us that we are competent enough because these users already have their own national facilities. They have the European Synchrotron Radiation Facility, the ESRF. However, they also apply for their projects to be conducted at SESAME, and this gives us a high level of competitiveness and advancement as well. Not only that, all those are highlighted in red are the newcomers. The new African users are coming to Sesame either for activities or for training or for conducting projects at the facility. We have benefited a lot from so many EU projects, and currently we are also having training programs in collaboration with the EU with another focus on Africa. These are some examples of some research that has been conducted at the facility on Alzheimer, on preeclampsia, on diabetes, as well as on breast cancer. We have also novel insights on energy, waste management, catalysis. We had users working on these from Egypt, Turkey, Jordan, Pakistan, and Italy. We're also having a lot of experiments on environment and water harvesting for those national benefits that what we can say about it. For example, from United Arab Emirates and Jordan. And again, to have a sneak look at the history, we had a lot of experiments on mummies and human remains from Malta, United Kingdom, Spain, Egypt, Cyprus, Turkey, Netherlands, and Japan. We had also experiments on ancient fossil record of Earth and potentially Mars. That was a nice collaboration between Iraq and UK. Also collaborations in other aspects of cultural heritage archaeology. For example, we had an experiment on the 16th century Ottoman tile from the Dome of the Rock in Jerusalem with users from the United Arab Emirates. And again, more collaborations between Egypt and Belgium on Egyptological findings. I don't want to end without bringing your attention to the other sides of the world. Those are still lacking this kind of technology. Africa is the only continent that has no synchrotron light source, and for some years now we are giving a lot of attention to this, and I would say that we are with the African Light Source Foundation. We are giving a lot of efforts towards a light source for the African continent. And again, I'll never skip mentioning that for Latin America is only the Brazilian light source that exists there in Brazil. But again, there are a lot of efforts that we are doing to enhance and to enrich Latin America with more synchrotron light sources for the Caribbean, the Mexican, and so on. Of course, to end this presentation, I would not say that science can save us or can save Sesame or can save the Middle East, or that Sesame can save the Middle East. However, the only fact that we know very well is that science alone cannot solve our political, our economical, security issues that we are facing today. But we are also confident of what we saw, of our experience, that science diplomacy can help us, as it already helped us before. We hope that it can still help us to address our health, environment, energy, water, and food challenges that in a way or another are contributing to our regional instability. Before leaving you, I'd like to share with you a quote, a saying that crossed my path recently about success, which I find it so much coherent with our story about Sesame. It says, "The plain fact is that the planet does not need more successful people, but it needs desperately more peacemakers, healers, restorers, and storytellers. It needs people who live well in their places. It needs people of moral courage willing to join the fight to make the world habitable and humane. And these qualities have little to do with success as we have defined it. I really hope that we, scientists, can go beyond the traditional definition of success that goes only around the technical or scientific achievements and development. I really hope that we can take our knowledge beyond that to heal our distorted humanity, to overcome our challenges, to bring us back to harmony and peace as much as possible. Thank you so much.